Hey, well, I thought I'd do a quick video showing some of the stuff I've been playing with. Completely nonsensical, but it's amusing the heck out of me, so it might as well amuse you too. So what I've been doing is sort of expanding the debug system in Classic99, the external debug system, the one I never told anybody about or activated before. I'll probably push this version out next week. But the point of this is it shares VDP RAM as shared memory, which means any Windows application can access it. Sharing CPU RAM right now is too complicated. Classic99 version 3 is probably not going to be able to do it. But video RAM, it can do. But this is actually still kind of useful. So the interface is twofold, right? There's a packet-based interface that lets you send command packets to access anything in the CPU memory space. So from that, you can access VDP, you can access sound, you could access speech if you wanted to. It should all work. But VDP access, over UDP packets, particularly a byte or two at a time, is pretty slow, like slower than TI slow. So what I did by sharing the video memory is now the host PC can access the emulator's video RAM directly. And so I've been hacking on LibTI99 to provide an abstraction layer that lets me run LibTI99 applications on the PC, but output through the emulator so that you can test the graphics. You can test, hopefully the sound. I haven't got as far as testing that yet. But everything should, in theory, just work. And so what I thought I'd do, the big advantage of this is, of course, you can debug on the PC with the full power of PC debug tools. Here I'm going to use Visual Studio since it is a Windows application. But yeah, you know what? Let's just go ahead and do it, right? So I'm just going to go ahead and set a breakpoint here. Classic99, as you can see, is already up. I think you can see my mouse cursor. Good. So all I have to do is hit run. It's already built. All right. You can see that something has happened, and what's happened so far is the, let's go ahead and open the debugger in Classic99 and go into disassembly, and what you can see is it's in an infinite loop. So what's happened is the startup code for libti99 uploads this jump to same address, so the infinite loop, into CPU RAM. Then it hacks the interrupt function to jump to that. So basically, the CPU in Classic99 is now busy. It's not going to do anything else, and therefore it won't interfere with your debugging scene. It appears that some registers may have been updated. To be completely honest, I don't remember the full startup sequence. Oh, that's right. I think it detected F18. Anyway, whatever it did doesn't matter right now, because what matters is we are in control and we are breakpointed. So let's go ahead and we can literally just step through this code. So, okay, set text. Sure, sounds good. Now it's in text mode. Jar set lowercase. Hey, look, our character set's loaded. Set text color. Yeah, that looks right. Background color. Well, didn't change. Clear the screen. Include tests. And let's try just jump down here. Let's say run to cursor. And of course, it's waiting for a key press. So I can just come over here and say yes. And now we can come over here and we can actually see in the debugger the Kscan key. Really important to emphasize, this is not debugging on the 9900. This is debugging on the core whatever I have in my Pentium PC. So this is running a 32-bit application on the PC, which means it's not completely one-to-one, but for approving logic for debugging tricky sections of code, it's quite nice. In addition to all that, it's bloody fast. How fast is it? I'm just going to let test bitmap mode run. Hello, bitmap. Now, I don't know if you've ever seen this code run before, but you have some idea how fast bitmap mode should go. Pixel test, it's gone already. That block that's blinking at the top is a bug I introduced in TestLib. Sorry, I know that makes for a bad video. It's the cursor flashing because I switched to ConIO polling. Never mind that. Anyway, so I don't know if you remember the speed that these lines normally draw at, but it's 20, 30 seconds, right? Oh, whoops, sorry. We've got control back over on the debugger here. Set text, all right. I'm just going to let the rest of the program run. Here we go. So this is why you'll notice right here. So notice that size of int is 4, size of long is 4, size of float is 4. This is because this is running PC code. It's not running 9900 code. That's very important. It's just redirecting all the output out through the emulator. Okay, we have some screen colors, press keys. Okay, we'll draw some lines at ConIO, test printf. I mean, testing printf, not much of a test given it's testing on the Windows box, but it is testing libTI99 at least. Okay, and you can see, you can't even see it scroll, like it's not repainting the screen, it's scrolling the screen. And you're going to see that in a moment because we're going to run the F18 tests, and the F18A accelerated scrolling is slower than this. Here it is. This is the F18 one. So you can see that F18 GPU code can still run because it just gets uploaded to VDP and you set the VDP registers. So the emulator is taking care of that, even though we've hijacked the host CPU and are doing everything else externally. That's 30 row mode, which of course Classic99 doesn't do yet. Sorry. And this screen's always screwed up. I haven't fixed that yet. Cool. Yeah, so why am I doing this? Well, I want to test a fairly big program that runs on Tippy to run on the web, and there was a lot of little niddly fiddly things that I didn't want to have to debug live on real hardware, especially with all the file system access running across the internet. So just cheating a little bit. Not ready to show that off yet. We'll show that off when it's working a little bit better. But so far, so good. It has helped a lot to be able to do this. Now, hopefully, it will prove out when I try to port it to the actual TI. But since the code is written in libTI99, in theory, it should mostly go smooth. Anyway, that's all I wanted to show. Bye-bye.